Number 10, on the set of axes below, graph the function y is equal to the absolute value of x plus 1. So again, here's an equation. What kind of equation is it? Absolute value equation. Okay, so automatically I know it's going to look like a V, because that's what absolute value equations look like. So you don't even need to do it on your calculator, but you can. Just do a couple of negatives, 0, and a couple of positives. Substitute it in. So the absolute value of negative 2 plus 1 is 1. The absolute value of negative 1 plus 1 is 0. Absolute value of 0 plus 1 is 1. Absolute value of 1 plus 1 is 2. And the absolute value of 2 plus 1 is 3. Okay, so absolute value in your calculator, if you want to go ahead and graph it, is the button to the right of 9. And then in the left column, it's the middle one, absolute value. Don't forget, a lot of kids forget that. They put in x plus 1. It's the absolute value of x plus 1. You need those bars on either side. And I have a function shifting going on here. So even though I know this is a v, typically if it was just the absolute value of x, the vertex v would be at 0, 0. But this is a horizontal shift because it's within the function, a shifting to the left by one spot. And I see that already with this point right here. So negative 1, 0 is where the vertex is going to be instead of at 0, 0. Negative 2, 1. 0, 1, 1, 2, and 2, 3. Okay, the same is going to go on this side. It's got the same pattern because you can do a reflection through the axis of symmetry of this graph. Go ahead and construct your lines and get your V. So state the range of the function. Range means y values. So what are the y values? Given this picture, knowing that it goes on infinitely. So that means we're looking at this here. So the y values start at 0, and it goes up to infinity because these continue to go out. So all values for y are greater than and equal to 0. So that's the range. And the domain at which the function is increasing, that's this portion right here. So x starts at 0, x starts at negative 1 and goes out towards infinity. Emma recently purchased a new car. She decided to keep track of how many gallons of gas she used on 5 of her business trips. The results are shown in the table below. Write a linear regression equation for these data where miles driven is the independent variable. Okay, so that means miles driven is x, and your output is y, number of gallons used. Writing a linear regression means we're going to put this into a spreadsheet. And then once you do that, you're going to give your columns a name. And then after you're done with that, you're going to hit menu 413. So linear regression is menu 413. Make sure you select what you labeled as the name for your x and y. So for my x, I labeled it MI, so I had to select that. And for my Y list, I labeled it GA, so I had to make sure I selected that. Sometimes that's easy to forget. And when you hit OK, you're going to come up with some variables. Okay, so my slope, M, is equal to 0.05. I have to round to the hundredths spot. You have to make sure you do that, so pay attention to that. My B is equal to negative 0.92. And now I can write it into my equation. So y is equal to m, which is 0.05, x minus 0.92. That's my linear equation. Number 8, Max purchased a box of green tea mints. The nutrition label on the box stated that a serving of 3 mints contains a total of 10 calories. On the axis below, graph the function c, where c of x represents the number of calories in x mints. So a serving of 3 mints represents 10 calories. We can designate that, so 3, 10 is in this area. So that means 6, 20 is the next coordinate. Then 9, 30, right? We put another 10 on there for another 3 mints. And 12 is another 4, we go up to 40, another 10. And 15, another 3 gives us another 10 on top of the 40, so that's up to 50. So you use a straight edge in order to draw the line here to connect the dots. I don't have that capability, so I'm going to do the best that I can to draw it freehand, but you don't draw it freehand. You use a straight edge. So the next thing I'm going to do is I see my y-intercept is at 0, so that's my value for b. And my slope, if you look from one point to the next, up 2 over 3, up 2 over 3, up 2 over 3, that is the slope. So now writing it in equation is y is equal to 2/3 x. That's it. Plus or minus 0 is the same thing, so we don't even use 0 here. It's understood to be 0. Number 9, David has 2 jobs. He earns $8 per hour babysitting his neighbor's children, and he earns $11 per hour working at the coffee shop. So that's important information for sure. Write an inequality to represent the number of hours x babysitting and the number of hours y working at the coffee shop that David will need to work to earn a minimum of $200. So a minimum is at least 200. So that's $200 or more. And David worked 15 hours at the coffee shop. Use the inequality to find the number of full hours he must babysit to reach his goal of $200. So this is basically find x. Okay, so the inequality is 8x plus 11y is greater than or equal to 200. So since David worked 15 hours at the coffee shop, that goes in for y. Go ahead and multiply the 11 and the 15 and solve this inequality. Very similar to solving an equation, you're going to use inverse operations. Okay, subtract 165 from both sides. Bring down the 8x. The difference of 200 and 165 is 35. Divide that by 8. So it says use the inequality to find the number of full hours he must babysit to reach his goal of 200. So he must work at least 4.4 hours. So the number of full hours he needs to work is 5 hours. So he needs to babysit in order to reach his goal. Number 6, Riker is given the graph of the function y is equal to 1/2 x squared minus 4. Automatically, you look at that equation, you should say to yourself, oh, I see x squared here. That means I have a quadratic function. I may want to factor this. I may want to solve this using the quadratic formula. I may want to solve this using completing the square. These are all the things you should be thinking about. However, I see a graph given here. He wants to find the zeros of the function, but is unable to read them exactly from the graph. Find the zeros in simplest radical form. So that's the same thing as saying, find where this graph hits the x-axis, which is right here, these 2 points, in simplest radical form, meaning these have decimal equivalents, so we can't use factoring. We have to use quadratic formula or completing the square. But because this particular quadratic is missing the bx, or the middle term, I can actually use an alternative method, which you can't use 100% of the time. You can only use it here. I'm going to set this equation equal to 0. So I'm going to put 0 in for y. That's how you get the zeros. I'm going to add the 4 to both sides. Times 2 times 2, I got 8, is equal to, these cancel out here, x squared. Take the square root of both sides, because that's what you do to reverse the process of squaring a number. And this breaks down to 4 times 2. The square root of 4 is 2, and the other 2 stays under the radical. And it's plus or minus. I forgot to put that there, sorry. Okay, so we have 2 roots, 2 zeros, that is, same thing, plus or minus 2 radical 2. Those are the 2 values. Number 4, on the set of axes below, graph the function represented by y is equal to the cubic root of x minus 2 for the domain -6 is less than or equal to x, which is less than or equal to 10. So what I would do if I were you is I would draw a table. I'd start it at -6 and increase it all the way up to 10. Then I would go ahead on my graphing calculator and insert this graph. And the way in which you do that, because it's a cubic function, all right, that little 3 on the outside of the index there, the way in which you put that in is you're going to have to hit Control, and then 2 buttons down from Control is an upside down V. That's the nth root of x. You're going to hit that button. You're going to put 3 in for the index, and then underneath the radical x minus 2, hit enter. Get your graph. So it's going to look like a squiggly. So if you hit Control T, you're going to go or scroll all the way up to -6. That's a nice number right there, -6, -2. Okay, and the rest are decimals. So just take the nice numbers, and the rest will fall in line. So 1, -1 works out. 2, 0. 3, 1. And 10, 2. Okay, so I'm going to try to erase some of these other ones because it's taking up a lot of room and I don't need all of them. I'm just going to jump to 10. Okay, so let's go ahead and graph. And I'll do the best that I can on this graph because it's not very successful. So 1, 2, 3, 4, 5, 6 to the left, down to, there's 6, -2, go down or over to 1, -1, 2, 0, 3, 1, and 10, 2. Okay, the specific domain restriction is between -6 and 10, including those values. Do not put arrows, even though this graph continues on, because of this restriction. It's always on a Regents exam, the restriction, so please pay special attention to it. And that's all you have to do. If you want to put the equation here, it's probably a good idea. And that's the name. So this number 5 is asking you to solve 8m squared plus 20m is equal to 12 for m by factoring. Okay, the first thing I need to do is to get this equal to 0. So I'm going to subtract 12 from both sides. I believe I can factor out a GCF of 4, and get 2m squared plus 5m minus 3 equal to 0. Now this is a little bit harder way to factor, so I'm going to break up the 2m. Okay, so I need factors of 3, and then you're just going to have to check it. So if I put plus 3 here and minus 1 here, right, -1 times a positive 3 is going to give me a -3 when I multiply the two. But when I multiply these two, I get 6m, and I multiply these two minus 1m, and then I find the sum of these two, I get a positive 5m, which works out here. So these are my set of factors. I'm going to set them each equal to 0. So 2m minus 1 is equal to 0. Add 1 to both sides. Drop the 2m and divide it out. So I get 1/2 is one value. And then the other one, which I'm going to do in red, m plus 3, you already know it's the opposite value. So m is equal to a -3. So my solutions are 1/2 and -3. Regents Review Packet number 1. Which ordered pair is not in the solution set of y is greater than -1/2 x plus 5 and y is less than or equal to 3x minus 2? So since these are both inequalities in terms of y, all you have to do is graph them very similar to an equation on the calculator, and you'll get two lines very similar to, or exactly the same as what I've created in red. Now the one in red represents y is greater than -1/2 x plus 5. However, it's supposed to be a dashed line, so I'm going to use my black color here to represent this red line as a dashed line. So that means any point that lies on this dashed line is not going to be included in the solution set. And as far as the second inequality, that's represented as the blue line, and it is solid. So since all the values for y are greater than this red line, I shaded above the line, and for the blue line, all values for y are less than, so that's below the line. And as you can see where the blue and the red overlap, that is our common solution set. So if we check each of these values, the first one is 5, 3. So on the graphing calculator, you'll be able to tell a little bit better than my picture here what solution or ordered pair is in the solution set versus not in the solution set. So we're looking for the one that's not. 5, 3 works, so choice 1 does work, so we can't use that as the answer. 4, 3 doesn't appear as though that will work, and we'll just check that algebraically and make sure. 3, 4 doesn't work, as well as 4, 4. I mean, they do work, so they're not the answer. If you take the first one, y is greater than negative 1/2 x plus 5, and we substitute the values in for x and y. So is 3 greater than negative 1/2 times 4 plus 5. So this ends up to be negative 2 plus 5, which is a positive 3. And 3 is not greater than 3, so this is the choice. So I just proved it to be the correct choice because it doesn't work. It doesn't prove this inequality to be true. Number 2, if the quadratic formula is used to find the roots of the equation x squared minus 6x minus 19 is equal to 0, the correct roots are, so you need to get the quadratic formula from the back of your Regents exam booklet, and I'm going to write that over to the right here. X is equal to negative b plus or minus square root b squared minus 4ac all over 2a. So first and foremost, you must make sure that you transfer that formula from the back of the Regents very carefully and very explicitly to your paper. Pick out your a, b, and c. So the coefficient of x squared is 1, so that's your a. B is negative 6, and c is negative 19. So let's plug it into the formula. X is equal to a negative 6 makes it positive, plus or minus square root negative 6 squared minus 4 times 1 times negative 19 all over 2 times a, which is 2 times 1. First step, you need to do what's under the radical first without using the radical symbol. So negative 6 squared is positive 36. And then a negative 4 times a negative 19 is going to give us a positive 76, all divided by 2. And then combine that with 36, when we get 112 under the radical. Okay, so 112 simplifies further. 16 times 7 is equal to 112. So 16 is a perfect square, so that's the square root of 16 is 4. Radical 7 divided by 2, and that simplifies to 3 plus or minus 2 radical 7. So here's your answer, choice 2. Number 3, which statistic would indicate that a linear function would not be a good fit to model a data set? Okay, so there's two ways to represent a data set. One of them is using residuals, and the other one is using correlation with regard to a regression line. As you can see, they have two ways here. The first two is correlation, and the second two is residual. So these are very strong correlations. If you get a number that's very close to or on -1, or you get one that's +1, being that it's a strong correlation, that means it is a good fit. With regard to the residuals, choices 3 and 4, the more scattered it looks, or the more closer to the x-axis it is, it's a good fit. So the only one that's not a good fit is choice 3, because there's a pattern.